Hey everyone, and welcome to the final episode of my motion tracking in Blender series. In this episode, we'll focus on finishing the shot. I'll show you where to find free 3D models and how to import them into Blender, how to match CG to real footage with realistic lighting and reflections, and a complete compositing workflow with color adjustment tips and cinematic effects. We'll also wrap everything up by adding sound effects and music, and editing the final result in Blender's video editor. Everything in this tutorial uses free tools and resources, so you can follow along and reuse this full workflow for your own project. I'll also point out what's new in Blender 5.0 along the way, so whether you've already updated or you're still on an older version, you'll still be able to follow along without issues. Let's get started. In the last episode, I showed you both the quick and manual methods of camera tracking and solving the camera motion. Then we set up the scene and used the restriction toggles to render only the object in the foreground and only the shadows in the background collection. Now, let's start this tutorial by deleting the sphere and replacing it with our own 3D model. There are several websites where you can find and download 3D models. Let me show you some that I use. First of all, you might be familiar with downloading textures and HDRIs from Polyhaven, but did you know that they also provide high-quality, royalty-free 3D models? If you go to Assets and then Models, you can find a variety of free models to use. I'll download this side table. Choose 4K, select the blend format, then press Download. Extract the files and save them in your project folder. Another awesome tool for downloading 3D models is BlenderKit. You can pay for a subscription, which I've done before when I needed many of their paid models at once. But they also have a free plan, which I'm on right now, that includes tons of models you can use for both commercial and non-commercial projects. It can really come in handy when you just need to grab some models quickly. The easiest way to use it is to download the BlenderKit add-on. Go to blenderkit.com, press download BlenderKit, and then download the latest version. Open your Blender project again, go to Edit, then Preferences, and then Add-ons. In the arrow drop-down menu, select Install from Disk. Find the BlenderKit zip file, then press Install from Disk again. I already have it installed. Make sure that the add-on is enabled, and then press Save Preferences. Save your blend file, and then I like to restart Blender just to make sure the add-on is properly configured. Before we move on, I just want to share some additional websites where you can find free 3D models. First, most of you have probably already heard about Sketchfab. Just go to their downloadable content and toggle on the free standard license to find royalty-free models. The CC0 license also works, and credit is not mandatory, but the rest of the licenses require you to credit the author, which of course is not a terrible thing. It's always nice to give recognition to fellow creators, but sometimes you just want to avoid any sort of obligations. If you couldn't find what you were looking for on Sketchfab, there's also CG Trader. Go to 3D models and browse their categories or search for a specific model, then toggle on Free to find royalty-free models to use. You can also check the licensing information on the download page to make sure the model is free to use. OBJ and FBX files usually work best in Blender. Next up, we have Blend Swap. All the models here are free to use and are made to work in Blender. Just pay attention to the licenses, as CC0 models don't require attribution, while CC BY models do. Then there is Quixel Megascans, which has now been merged into and is available on Fab. Here you can find many high-quality 3D models available under the Fab standard license, which allows use in both personal and commercial projects. Another cool website is 3D Scans, which contains a library of, yeah, you guessed it, 3D scans. They have a bunch of realistic 3D scans of statues and historical artifacts from museums that have generously been made available to download and use for free. These are websites that I have often used for both personal and commercial projects. If you know any other good websites for downloading 3D models, please share them in the comments. If these websites look useful and you want more free resources like this, don't forget to like the video and subscribe. Now, let's add the models that I'll be using for this project. I'll start with the model that I downloaded from Polyhaven. Start by opening the blend file containing the model. Select the model and press Ctrl+C to copy the objects. Go back to your project file, press Ctrl+V, and the model will be pasted straight into your scene. Next, let's use the Blender Kit add-on. After installing Blender Kit, you'll get a search bar over the viewport. I'll search for a telephone. The models with the lock icon require a premium subscription, but this black telephone is free. There are two ways to download a model. You can drag and drop it directly to where you want it in your scene, or you can click on it and it will load at the position of your 3D cursor. Models downloaded from Blender Kit are stored in a folder called Assets, and this folder is created in the same directory as your blend file. Now that we have our 3D models, let's position and adjust them a bit. I thought that the idea of an old telephone ringing in this empty tunnel could create a sense of suspense and an eerie mood. What do you think of when you see this tunnel? Have fun and download models to create a little story that inspires you. To keep things simple, I recommend placing your models in the center, where the track is the most stable, but feel free to play around. I'll quickly go through how I set up my models, and then we'll jump into the next part of the tutorial. I'll start by positioning the telephone on the table and making sure it's centered. The model fits the scene overall, but the wire extends past the edge of the tabletop. Sometimes downloaded models need small adjustments to work in a specific scene. I separate the telephone wire from the main model so I can adjust it independently. Using sculpt mode, I reshape the wire so it sits naturally on the table surface. I mainly alternate between grabbing, inflating, and smoothing to clean up bends and folds. Throughout the process, I switch views to check the shape from different angles. I also preview it in render view to make sure the texture still looks correct. Next, I add a second wire coming out from the back of the telephone by extruding it from a single vert. The single vert object is available after installing the Extra Mesh Objects extension and enabling it in add-ons. I block out the path of the wire and then convert the mesh into a curve object. I give it thickness and refine its smoothness. For the material, I keep it simple. I use a dark base color and add subtle roughness variation so it doesn't look too perfect. After that, I make sure that the wire sits properly on the ground. Originally, I planned to have the wire coming up from underneath the railing, but my track wasn't steady enough to keep it from clipping with the railing, so I decided to leave the wire cut off while the phone keeps ringing. Maybe that could even help make the scene feel more mysterious. Sometimes you have to improvise. Lastly, very important, make sure that all of your 3D models are placed in the foreground collection. Alright, with that done, all of my models are set up the way I want. Next, let's start thinking about the lighting in our scene. The default overcast HDRI that I'm using is good for creating natural fill light, but since it's nighttime in the footage, daylight might not be the most realistic option, so I'll go to Polyhaven again and download a nighttime HDRI called Cetera Night No Lamps. Place it in your project folder and then jump back into Blender. Next, go to the shading workspace. Change the shader type from object to world. Click the cross icon to remove the previous HDRI. Then locate and open the new HDRI you downloaded. This will act as a natural nighttime fill light for us to continue building on. Now create a new collection and name it Lighting. You can delete the old point light. Let's try to recreate some of the lighting that we see in the footage. I'll start with the light that comes from almost directly above the object. Press Shift S and choose Cursor to World Origin. Then press Shift A and add an area light. Move it so it's roughly in the same position as the light in the footage. The light's size and exact position don't need to match perfectly with the footage. What matters most is the actual lighting on the model and that the light comes from a direction that makes sense. Switch to rendered preview to see how it looks. Right now, since we're in the foreground layer, we can't see the shadows. In the upper right corner, click Add View Layer, then choose New. This creates a new view layer with all collections enabled and without restriction toggles. You can rename this layer to All. We'll only be using this layer for previewing the scene, and we don't want to actually render it, so go to the View Layer properties and disable Use for rendering. Now that we can see all of our layers together, let's continue adjusting the lighting. Let me show you a technique for creating realistic interior lighting. With the area light selected, go to the Light Object Data properties. Here click Use Nodes. Go to the Shading workspace and switch the shading type back to Object. You'll see that two nodes have been created. One is an emission node that controls the strength of the light. The other is a light output node, which sends that result to the actual light. In the Object Data properties, click the color field and choose Black Body. This creates a black body node and adds it to the emission color. The black body node allows us to adjust the color of the light using Kelvin values. Kelvin values represent how warm or cool a light appears in the real world. You can search online for Kelvin light values to find reference charts that show how different temperatures affect light color. In Blender, the temperature value defaults to 1500, which creates a very warm orange light. I'll change this to 4500 instead. This gives us a more neutral light with a slightly cooler tone. You can leave the black body emission strength at 1. Instead, use the area light power value to control the brightness. I'll increase the power to around 30. Looking at the footage, the light source appears to be more in front of the object, so I'll move it a bit toward the camera. Then I'll also scale it up. Scaling an area light makes the light softer. I think this looks pretty good. Now let's add another area light to simulate the light coming from the back. I'll duplicate the existing area light so we keep the same settings. Then press Alt-S to reset the scale. I'll move the light back and down a bit. Then I'll rotate it toward the back of the telephone table. After that, I'll move it slightly to the left, so it roughly matches the direction of the light we see coming from the far end of the tunnel. Let's take a look. The backlight creates a silhouette around the objects and looks pretty cool. We can make it a bit softer by scaling it up. Right now it's also way too strong, so I'll reduce the power maybe down to around 5. To make most of the light come from the left side, I scale it down on the x-axis, but since the light is smaller, it also becomes a bit sharper and more intense. I'll lower the power of the light again. I think I'll lower it all the way down to 0.5. The surrounding areas in this section of the footage look quite dark, but I'll leave the final adjustment up to you, as it will also vary depending on the scale of your model. I also want a bit of light coming from the sides. I'll duplicate the backlight, move it roughly to the edge of the wall, and rotate it toward the object. Then I'll duplicate that light and place it along the wall on the other side and rotate it toward the object as well. Next, I think I'll move the model slightly to center them in the archway and position them more directly under the ceiling light. To select all foreground objects at once, right-click the foreground collection and choose Select Objects. I think that's enough for the lighting. I'll turn off the visibility of all the lights. Then I'll turn them on one by one to check how much each one is contributing. I'll also rename them in the process to stay organized. First, we added a nighttime HDRI to create a base fill light. Then we added an area light to simulate the ceiling light. Next, another area light to simulate the light coming from the back. Finally, lights on the sides to capture the light sitting on the walls. Let's compare this setup to using only the overcast HDRI we started with. It's pretty evident that the daylight HDRI made the model look totally out of place. After adding our own lights, the model matches the brightness and temperature of the scene much better. Even if you're not a lighting expert, spending some time trying to match the lighting to your footage goes a long way. Before we move on to compositing, I want to talk a bit about reflections. Right now, some of the light bounces off the surface of our shadow catcher and onto the model. We can see this by toggling the visibility of the shadow catcher plane on and off. The color and intensity of the bounced light are determined by the properties of the surface's material. We haven't given the shadow catcher a material yet, but it still reflects light because Blender treats all geometry as having a default diffuse surface, and the reflection comes from the render engine's reflection system. To have more control over the reflections, we can give the shadow catcher a new material. I'll split open a new window, set it to the shader editor, and add a new material. If we change the base color, the reflected light we see on the model will take on that color. A simple and quick way to get the reflections to match the color of the ground in the footage is to use the color dropper tool to select the ground color. The reflected light now becomes darker, matching the ground color better. This happens because the diffuse bounce light changes, which is directly affected by the base color. However, the shadows and reflections on the ground also change. This is because the roughness and specular reflections become much more noticeable depending on how bright or dark the surface is. Very bright or white surfaces have extremely high diffuse bounce light, which visually overwhelms specular reflections. As a result, changing roughness or specular values on a bright surface often appears to have little effect until those values are pushed to extremes. Darker surfaces, on the other hand, absorb much more light. This reduces diffuse bounce and makes the surface far more sensitive to glossiness and specular reflections. For a matte surface like this ground, we don't want any glossiness or specular highlights at all, so we reduce the specular all the way to 0 to remove those specular reflections. Then we increase the roughness to 1, making the surface fully diffuse, so it only tints the reflected light without introducing any glossy highlights. Next, instead of using the color dropper tool, we can also use the image sequence of our footage as an input for the base color. With the principled BSDF selected, press Ctrl T to automatically set up the image texture, mapping, and texture coordinate nodes. Then click Open on the image texture node. Find the footage image sequence, press A to select all, and click Open. To see the texture, go to Object Properties and temporarily turn off Shadow Catcher under Visibility. At first, the image just appears black. That's because we're using UVs as the texture coordinate input. We aren't going to UV unwrap the ground right now. Instead, let's use Window as the input method. This projects the texture in screen space, essentially projecting the texture exactly as we see the image through the camera. If we move forward in the timeline, we can also see that the image repeats itself on the geometry outside of the camera view. You can press M to mute and unmute a node to update the texture in the viewport. To make the texture a bit more consistent, we can change the extension type from repeat to mirror. Now the floor extends more naturally instead of cutting directly to the ceiling part of the texture. Next, we want to make the color of the ground plane match the surrounding footage a bit better, because this will also make the reflected light match that color. You could try adjusting the temperature of the lighting. For example, setting the Kelvin value to 6000 might be a closer match to the lighting in the footage. But I already like how the lighting looks on the model, so instead, let's adjust the material of the ground plane. Press Shift A, search for a gamma node, and place it between the image texture and the principled BSDF. The gamma node controls the overall brightness of the image, and by lowering it, we can make the pixels brighter. This will make the reflections on the model a bit brighter as well. The tint of the ground still isn't an exact match, because our lighting is different from the real environment, so I'll also add a hue saturation value node and slightly nudge the hue to make it a bit more yellow. I think this is good enough, so I'll enable Shadow Catcher again. You can see that the gamma node slightly brightens the reflections. The change in hue, however, is quite subtle, since the model is small and dark in color. Finally, we can compare the result with and without the material. There isn't a huge difference, but small changes like this can add more realism to your CG, especially if you have a larger surface of geometry close to the ground. For example, if I add a large sphere, you can see that the reflections look much more natural with the gamma and hue correction than without them. Light interaction is also more physically accurate when using the principled BSDF, and the tint matches the ground better by using the image sequence as the base color. Before we move on, I also want to briefly show you how you can deal with reflections on objects. For example, If I add a principled shader to the sphere and decrease the roughness, we start to see reflections of the environment. Even more so if I give the sphere a darker color. However, the reflections we're seeing right now are coming from the HDRI and the ceiling area light. I'll select the ceiling light and turn off glossy under visibility so that we don't see its reflection. Now the only reflections of the actual footage we see are coming from the floor with the image sequence texture. We can use a similar approach to project the surrounding environment by adding geometry to the walls and ceiling. I'll edge select both sides of the ground plane in edit mode and extrude them up over the ceiling light. Then I'll press F to fill the ceiling with a face. I'll fill the back with a face as well. Then I'll select all faces except the ground and press P to separate them into their own object. I'll name this object Reflections and put it into a separate collection. I don't want shadows or diffuse lighting to be cast from this object, so I'll disable Shadow Catcher, which it inherited from the ground. What I want is for the reflections from this object to appear on our 3D model without the object itself being visible in the render. To do that, we can use the Indirect Only filter again. Reflections are an indirect effect, so when we enable Indirect Only for the Reflections collection, the reflections remain, but the object itself becomes invisible. However, we can still see a visible line where the environment geometry meets the ground. This happens because the object is still casting diffuse light and shadows onto both the 3D model and the ground. To remove this, select the Reflections object and disable both diffuse and shadow rays. Now the only thing that remains visible is the glossy reflection, which is exactly what we want. For this workflow, I only want to use this geometry as reflection cards, and I don't need any realistic light interaction, so I'll make the material a single user copy, then delete the principled BSDF, gamma, and hue nodes. Now these walls are no longer behaving like physical surfaces, they are only visible to reflection rays, so the object directly samples the image sequence as a part of its reflected environment. Another issue appears when we move forward in the timeline. You can mute and unmute a node to force the texture to update. The parts of the geometry that are outside the camera view get mirrored from what is visible in the frame. I'll turn off the Indirect Only filter for the Reflections collection so we can see what's happening. We want the texture to remain static and not change frame by frame. To do that, I'll go back to frame 1 where we can see most of the scene. Next, I'll go into edit mode and extend the walls and ceiling so they fully cover the camera view. Then I'll press A to select all, press U and choose Project from View. Now the image texture has been projected directly onto the UVs, so we can switch the texture coordinate output to UV. However, the image looks heavily warped. That's because the object needs much more geometry to display the image correctly. So first I'll add several loop cuts to create more even squares, then subdivide the mesh by around 20. After that, I'll press U again and choose Project from View. With the added geometry, the image looks sharp again. But if we look closely at the reflection, we can still see distortion where the image starts to mirror. The HDRI is also still visible at the end of the tunnel in the reflection, which may or may not be what you want. Maybe there's a night sky outside on that side. But I don't want that, so to fix this, I'll Alt left click to select the edge loop just before the ceiling goes out of frame. Then I'll go into side view, enable X-ray, shift box select the remaining geometry and delete it. I'll set the 3D cursor to the middle of the bottom two vertices of the geometry. Because the image texture is now baked onto the mesh, we can move the geometry and the texture will follow. Then I'll press A to select all, set the pivot point to 3D cursor, press Shift D to duplicate and RZ 180 to flip it. Now the reflection looks like the other side of the bridge continues further into the tunnel, and we avoid the mirroring artifacts. You might see a slight seam where the two parts meet, but since objects are rarely perfectly reflective, slightly increasing the roughness makes it barely visible. You can also extend the floor a bit, and I think just leaving the mirroring of the image is enough for it. We also now see the back of the tunnel in the reflection instead of the HDRI. Finally, I'll enable the Indirect Only filter again. To render this, you can disable the Reflections collection entirely in the background view layer and enable Indirect Only for it in the foreground view layer. This is how you can achieve realistic environment reflections when rendering smooth reflective objects. However, if I hide the sphere, my telephone is looking a bit flat. That's because I disabled glossy reflections on the ceiling light, so we lost its contribution. In this case, I actually think it looks better with those reflections enabled. For the rest of this tutorial, I don't have reflection geometry or a special ground material. This is just because this section was added after the tutorial was already recorded, and I wanted to give you as much extra value as possible. Your final result will likely look even better than mine if you choose to apply these additional details. Next, we'll move on to compositing and prepare to render out our layers. The first thing I want to show you is how to set things up so we can use denoising in the compositor. To do that, we need to add an extra pass to our render. Remember that we're currently in the combined all layer. We want to do this in the foreground layer. Enable denoising data. We don't need to denoise the background layer. Shadow catcher layers are often left without denoising because they're used as clean shadow masks, and denoising can soften or smear shadow detail. If we want to soften the shadows later, we can simply add a blur node in the compositor. This workflow is all about having more control. Press F12 to render the image. Actually, jump to the last frame, since that's where the object is closest to the camera. Then press F12 to render the image again. Then go to the compositor workspace. Backdrop is enabled by default, but I prefer another way to preview the render. Open a new window on the side and set it to the image editor. Since our node tree is connected to a viewer node, we can select it from this drop-down menu. Now we can see the changes we make to the render over here instead of behind the nodes, which is how I prefer to work. And we can disable backdrop. Since we added denoising data in the view layer properties, we have a couple of extra denoising outputs in the foreground render layer node. Press Shift A and add a denoise node. Now connect the denoising normal and denoising albedo outputs to the denoise node. With this setup, the denoising happens in the compositor. That means we can disable denoising in the render properties. Press F12 to render again. Zoom in on the 3D object and toggle the denoise node on and off by pressing M. And you can see that it's working. Denoising in the compositor avoids baking denoising directly into the render, giving us more control and allowing us to denoise layers separately. Being able to exclude denoising the shadows from the render process also saves us some time. Now, before we continue with the rest of the compositing, I want to render out the foreground and background layers as image sequences. This way, we can preview each frame of the animation without having to render them individually each time. The best way to render multiple layers at once is by using the File Output node. Press Shift A and search for the File Output node to add it. The base path is where the renders will be saved. The image inputs are used to connect our render layers. Select the File Output node, press N to open the sidebar, go to the Node tab and find the Properties drop-down. First, add two layer inputs so that you have one called Shadows and another one called Objects. Next, set the location where you want the renders to be saved. I'll create a new folder called Layers. You can leave the file name field empty. The rendered images will automatically be named based on the input names. Then I'll connect the background layer to the shadow socket and the foreground layer to the object socket. The File Output node output settings override the render output properties in the main side panel, but for some reason Blender still renders out extra files to the output path set in the render output properties based on the settings there. I haven't found a way around this yet, but we can do our best to prevent it. Disconnect the composite and viewer nodes by holding Ctrl, right-clicking and dragging. Also go to post-processing and disable sequencer. Sometimes this works, but just in case, set the render output path to a temporary folder, so if you get files rendered out there, you can just delete them. Next, I'll set the format properties of the File Output node to render out PNG image sequences again. This time I want to include the alpha channels, so I'll set the color data to RGBA. A few small changes were made to the file output node and its properties after Blender 5.0. There is now a new input field with the default text file name. This allows you to enter a prefix that will appear before the layer name in each rendered output file, but you can simply leave it blank. The PNG output format can be found under Image. Furthermore, under the Layer Images field, there is now also Socket Type. Socket Type tells Blender what kind of data is being written, so Color is used for images, Float for grayscale masks, and Vector for motion or direction data. We want to set this to Color for both our shadows and objects. Enabling Override Node Format lets us choose a different file format per output socket instead of forcing all renders to use the same format. But we will keep it simple and just render out everything as PNG 8-bit sequences. Next, set the resolution you want to render out in. If you're just practicing, you can leave it at 1080p for faster renders, but I'll render at 4K to get the best quality. Under color management, we can leave the view transform set to standard. Since we're compositing inside Blender, we want our CG to stay neutral. Blender's compositor works in linear space and expects unprocessed renders. If we bake a view transform like AGX into the render, the contrast and highlight roll-off are already applied, which limits our control later. By rendering in standard, we keep the CG flexible and apply the view transform once at the final stage, so everything goes through the same transform together. If you're compositing in other software, such as After Effects, it's common to render the CG with a view transform like AGX already applied. That's because those tools usually treat images as already finished and don't apply an extra view transform like Blender does. In that case, baking AGX makes the CG match the footage right away. After Blender 5.0, there is also a color management option called ACES. ACES is widely used in film and VFX pipelines because it handles high dynamic range camera footage more consistently, especially with formats like EXR, LOG, or RAW. However, the footage we're using here doesn't have that wide color range, so ACES wouldn't give us any real advantage, especially since we're compositing inside Blender. So for this workflow, we'll stick with standard. As a general rule, standard works best when compositing inside Blender, while AGX or ACES are more commonly used when compositing in tools like After Effects, New, or Resolve. Next, press F12 to test the file output node, then go to the output folder you specified. You should see two images there, one with the prefix shadow and one with objects. The prefix is followed by the frame number, which in this case is frame 250. Make sure the shadow image contains only the shadow and the objects image contains only the objects. I didn't get any random black images rendered out this time, so that's good. If everything looks correct, go back to Blender and press Ctrl F12 to render out the whole animation. You'll be able to see each frame appear in the output folder as it renders. Another quick tip is to add an underscore after the layer names. That way, the frame numbers are separated from the file name, which makes the file names clearer and easier to read. Once the rendering is finished, I separate the shadow and object images into different folders. This helps keep everything organized. I create a folder called Shadow. Select the first shadow image, scroll to the bottom, then hold Shift, then select the last image. Drag them into the shadow folder. Then I do the same for the objects images. Blender also rendered an extra file, as I mentioned earlier, based on the settings we previously had in the render output properties. You can safely delete it. Since we disconnected the composite node, it's just a pure black file and didn't really add any extra render time. Back in the Blender compositor, press Shift-A and search for Image Sequence. A file browser window will appear. Navigate to the folder containing the shadow image sequence. Press A to select all, then choose Import Image Sequence. Click to place the node. Now replace the background render layer with the shadow image sequence. Import the object's image sequence in the same way. Then replace the foreground render layer. Then you can delete the render layers nodes, the denoise node, and the file output node. Reconnect the alpha over output to the composite and viewer nodes. And now everything is set up in the same order as before. The difference is that we no longer need to re-render everything each time. Blender will automatically composite each frame using the image sequences. This speeds up the compositing workflow a lot. Alright, now it's time to start compositing. The first thing I want to look at is this Undistortion node. In Blender 5.0, it's just called Movie Distortion instead. If we select the node and press M to mute and unmute it, we can see the image shift. This happens because we ticked these boxes during the camera solving process, one of them being Radial Distortion. When we click Solve Camera Motion, Blender analyzes the footage and calculates distortion values that describe which type of lens distortion is present and how strong it is. There are two main types of lens distortion. If straight lines bulge outward, that is called barrel distortion. If straight lines bulge inward, that is called pincushion distortion. When using the polynomial lens distortion model, which is the most common model for regular lenses, having all values set to 0 means that no lens distortion was detected and the footage is perfectly straight. In this case, since the solved K1 and K2 values are negative, Blender has detected that this footage has pincushion distortion, meaning the image bulges inward. If those values were positive instead, the footage would have barrel distortion, meaning straight lines would bulge outward. K3 is an additional distortion value that fine-tunes the distortion curve without changing the overall distortion type. Here you can also see the optical center and focal length values that Blender calculated from ticking those boxes. But the distortion values are the only ones we need to focus on when working in the compositor. So once the lens distortion values have been calculated, this node lets us decide how to use them. If we mute the node and look at the footage, that is how the footage looks without any correction. The lens used to shoot this footage caused the edges and corners of the image to bulge slightly inward. When the node is set to undistort and we enable it again, Blender uses the solved distortion values to remove the lens distortion and straighten the image. During this straightening process, we lose a small amount of pixels around the edges, since the areas that bulged inward are pushed outward. There is also an option called Distort. If we use this option, Blender applies the same distortion values in reverse to add distortion back. So instead of correcting and straightening the image, it pushes the distortion even further and stretches the image inward. That is why we end up with transparent pixels around the edges. So we have a few options. We can delete the node and not make any changes to the footage, or we can keep the node set to undistort if we want to remove distortion and straighten the footage. But there is also another option. Instead of removing the distortion from the footage, we can add it to our CG. I can disconnect the node by holding Alt, clicking and dragging. Then I plug it in right after the foreground layer and set it to distort. This takes the distortion values calculated from the footage and applies them to the 3D objects. I'll duplicate the node and also add it to the shadow layer, so the shadows get distorted as well. The footage stays unchanged, but the CG now has distortion that matches the footage. The difference is subtle, but it can add an extra layer of realism. This is especially useful if your footage has strong distortion. Next, let me show you how to adjust the colors of each layer. There are several options for color adjustment in the compositor. Press Shift A, go to Color, and then Adjust. Here you can see the available color adjustment nodes. One I like to use is the Color Balance node. I'll hold Shift, right-click and drag to connect these node links. Then I'll place the Color Balance node after all of the layers so we can see its effect. This node essentially lets us adjust the shadows, midtones, and highlights of the image. The black and white sliders adjust the brightness of those tonal ranges. The color wheel lets us adjust the tint of each tonal range. And the box underneath simply shows the selected color. You can hover the cursor over a parameter and press backspace to reset it. This was recorded using Blender version 4.3. In newer versions of Blender, the color balance node looks different, but it serves the same purpose. The original black and white sliders have been replaced by numeric sliders, which now adjust the brightness of each tonal range. The color wheel used to adjust tint is now accessed through this color field. Inside it, there's also a black and white slider, but this one only controls the brightness of the tint color. By default, the color balance node is set to lift, gamma, and gain. Then there's also offset, power, and slope. Both affect shadows, midtones, and highlights, but lift, gamma, gain adjust the tonal ranges more directly, while offset, power, slope reshape them by shifting and scaling more of all tonal ranges together. What helps me is to think of lift, gamma, gain as mainly controlling brightness, while offset, power, slope mainly controlling contrast. Let's compare them side by side. Increasing lift mainly raises the shadow level, brightening the darker parts of the image without affecting highlights as much. Increasing offset shifts the overall brightness of the entire image up or down at once, affecting more of all tonal ranges together and reducing overall contrast. Decreasing lift darkens the shadows, while decreasing offset shifts all tonal ranges downward together, increasing perceived contrast. Increasing gamma adjusts the brightness of the midtones, making the image brighter and flatter. Increasing power increases contrast around the midtones, making shadows deeper and the image feel more punchy. Lowering both values has the opposite effect. Gamma reduces midtone brightness, while power reduces midtone contrast. This is where things might feel a bit flipped. Gamma makes sense, as raising the slider makes the image look brighter, and lowering it makes it look darker. Power, on the other hand, makes the image look darker when raised, but brighter when lowered. That's because offset, power, and slope use a different formula, which we won't go into. It's best not to overthink it, and just see gamma as increasing or lowering brightness, and power as increasing or lowering contrast. Next, increasing gain pushes the highlights brighter overall, increasing highlight brightness more directly. Increasing slope increases contrast in the highlights, allowing brighter areas to extend further. Gain makes bright areas go brighter very quickly, whereas slope tilts the curve around the midtones, so highlights are affected more gradually and mainly gain contrast rather than raw brightness. Lowering both values has the opposite effect. Gain reduces highlight brightness, while slope reduces highlight contrast. I know this might seem confusing. Comparing the two, lift, gamma, and gain feel more intuitive and give you direct control over shadows, midtones, and highlights. They're good for quick exposure fixes and small targeted brightness adjustments. However, I actually prefer using offset, power, and slope. They shape contrast more smoothly across tonal ranges and are less likely to clip highlights or crush shadows. Because of that, I find this model better for changing the overall look and mood of an image, rather than making isolated adjustments. Another benefit of the offset, power, slope model is that it uses ASC-CDL, which you can see in the parentheses next to its name. ASC-CDL is a color correction standard shared across different software. What that means is that lift, gamma, and gain can behave differently depending on the program. Offset, power, slope, on the other hand, use the same values in other software like After Effects or Resolve. This doesn't matter much if you render directly from Blender, since the final colors are baked into the image anyway, but it gives you more flexibility if you want to preview a look in Blender and then recreate that same look elsewhere using the same values. To help us out, Blender also provides color grading scopes in the end panel of the image editor. You can drag the panel edge to make it wider. Hold Ctrl and drag with the middle mouse button to scale the panel. The waveform shows the brightness levels of the image. 0 represents pure black and 100 represents pure white. Let's use this as a reference while adjusting brightness with a color balance node. I'll go back to the first frame to see more of the full scene. We can start by adjusting the offset. I'll lower it slightly to darken the entire image and deepen the blacks. You'll start to lose some detail in the shadows, but I'm willing to sacrifice that to get overall darker blacks. The red line in the Luma waveform in Blender is a reference for broadcast-safe black levels. It shows the lowest luminance level considered safe for traditional broadcast television. For web, film, or creative projects, it's perfectly fine to go below this line. If that's the look you're going for, you can even crush the shadows into pure black. So don't worry, it's just a guide, not a rule. I'll stay a little above 0 in the waveform to keep the exposure balanced and avoid crushing the blacks completely. Next, I'll raise the slope to brighten the image overall. This stretches the contrast range between shadows and highlights. You can push the value further by entering numbers manually, but that's usually not necessary. I'll increase it so the brightest parts of the image sit just below 100 in the waveform. Finally, I'll adjust the power, which controls the middle of the tonal range. This mainly affects the shadows and midtones, shaping how the image transitions into the highlights. Increasing it adds contrast, while lowering it creates a softer, more matte look. I'll raise it to about 1.1 to add a bit more contrast. I've already explained how the grayscale sliders control contrast by brightening or darkening the image, but we can also add color by adjusting the RGB values of these parameters. As before, the offset tint affects the entire image evenly, but when the offset is set to pure black, it has no effect. You would have to raise its brightness before any tint becomes visible. The power tint targets the midtones, and the slope tint targets the highlights. I can adjust the tints and press M to mute and unmute the node to see the changes. However, this also includes the contrast adjustment I just made. I only want to see the effect of the tint adjustments, so I'll undo the tint changes, add another color balance node, and place it after the first one. Now we can isolate and preview only the tint changes. We can also give nodes labels to stay organized. You can do this in the Node tab in the side panel. I'll name the first color balance node Luma, which refers to brightness without color. Then I'll rename the second one Tint. This makes the node setup easier to understand and manage. Now let's look at what adjusting the tint does. Before adjusting the tint, we can switch the waveform to Color Parade. This allows us to see the brightness intensity of each color channel. Below that, we also have the vector scope. This shows the hue and saturation of the colors in the image. Right now, we can see that yellow and red are the most dominant colors in the scene. As I mentioned earlier, changing the offset tint won't really do anything in this case, so instead I'll start by adjusting the tint of the power. If I drag the midpoint toward a warm color, something unexpected happens. The image actually becomes cooler. This is because the power control works in a counterintuitive way. Using the color wheel does not mean add this color. It means rebalance the other colors relative to the selected one. Blender applies a power-based color calculation to maintain balance. Without getting into the math, here's the key idea. Dragging the power wheel toward a color increases that channel's influence. To compensate, Blender boosts the other two channels. You can see this clearly in the color parade. When dragging toward red, green and blue rise. When dragging toward blue, red and green rise. And when dragging toward green, red and blue rise. So even though you drag toward one color, the result often looks like the opposite tint. This is simply how the power control works. The benefit is that Blender preserves color balance, allowing broad, natural-looking tint changes without crushing or clipping channels. Next, let's tint the highlights using slope. It behaves in a more straightforward, intuitive way compared to power. If you move the control toward red, the brightest parts of the image, the highlights, become red. And the same applies to blue, green, or any other color. Just like with the midtones, this is still done through balancing, but in this case, the channel is increased by reducing the other two. Using power to adjust the midtones and shadows helps shape the mood and atmosphere. Adjusting the highlights help create focus, contrast, or realism, depending on what you're aiming for. So you might drag the power toward a cooler color to create a warmer looking image, or drag it toward a warmer color to create a cooler look. Then you can push the highlights toward a color that complements the midtones, or push them toward a contrasting or completely different color for a stylized effect. This all comes down to artistic choice. You can recreate a look from a film or invent your own style. There's no absolute right or wrong. In Blender 5.0, the offset power slope wheels are more sensitive because the UI mapping was changed, allowing a wider adjustment range with smaller movements. This is useful when working with high dynamic range files like EXR or RAW, where broader color shifts are often needed. There are also 2 wheel modes available. Perceptual makes small movements near the center gentler and larger movements stronger. Linear changes the color at a constant rate as you move the wheel. These modes only affect how the wheel responds, not the actual color or final output. You'll usually reach a similar result either way, so it mostly comes down to preference and workflow rather than correctness. With that said, let me show you a more reference-based way of balancing color. We can use the color parade and the vector scope as visual guides to balance the colors. This is a common technique used to neutralize an image before any stylistic color grading. For this footage, it's honestly unnecessary since I'm working with an 8-bit PNG sequence and the colors are already baked in. This approach is more useful when working with high bit depth formats such as Camera Raw, ProRes, or EXR files, where you still have enough color information to properly balance the image before grading. I'll still show it briefly since it's a useful technique to understand. I can drag the power slightly toward yellow. This increases the brightness of the blue channel and reduces the saturation of yellow. Then I can drag the slope toward blue. This shifts the highlights toward blue by reducing the red and green channels. By doing this, the midtones and shadows also look more balanced. Another node that is great for fine-tuning specific parts of individual color channels is the RGB Curves node. C stands for Combined and lets you adjust all channels at once. You also have separate curves for the red, green, and blue channels. It's not as complicated as it might look. The middle of the curve controls the midtones, the upper part controls the highlights, and the lower part controls the shadows. If I want to increase only the highlights of the green channel, I can place a point in the middle of the curve to prevent changes from affecting the midtones. Then I can lift the highlights. I can do the same for the red channel. Finally, I can reduce blue in the slope to bring the green and the red midtones back into balance. So now we have more balanced colors in the highlights as well. At this point, the image looks a bit too dark, so I can adjust the curve in the combined channel. I'll switch back to the Luma waveform to check the overall brightness. Then I'll slightly lift the midtones of all channels, which also affects the shadows and highlights a little. Now the brightness and the color are more consistent across the image. If I mute and unmute the correction, you can see how much the image changes. This isn't meant to be a stylized grade. It's a neutral, reference-based balance. Whites become more neutral, grays stay neutral, and the overall color balance is more even. Because the colors are already baked into this footage, pushing it further would mainly be a creative decision. So I'll keep this balanced result as the final image and leave the styling and mood to you. I'll frame these nodes with Shift P and call them Combined Color. So far, we've adjusted the color for all layers at once, because I thought it would make demonstrating the color adjustment nodes clearer. But usually, I would start by trying to match the CG to the footage before doing any sort of creative modifications. I'll mute the combined color group and go to the object's image sequence. Then I'll add another color balance node right after it. This lets us adjust the object's colors before they're combined with the other layers. I'll close the Scopes panel since it shows values for the entire image and not just this layer, and then jump to the last frame so I can see the objects more clearly. Here I move the power toward blue, which brightens the red and yellow channels. Then I move the slope toward yellow to add some complementary warm highlights. Let's see how this looks together with the rest of the color adjustments. I might lower the power strength slightly to make the objects a bit brighter and less contrasty. I think I'll leave it there. Next, we have the shadows. The color balance node has no visible effect because the shadow pass is already near black, meaning both color and intensity information are essentially gone. Instead, a quick way to darken shadows is to add a set alpha node. Since the shadow layer only contains black shadows and transparency, increasing the alpha makes the black areas more opaque, which directly makes the shadows stronger. However, changing the color of the shadow is not as straightforward. If I add a color balance node, we still can't adjust the tint. So let me show you another method. I'll disconnect the color balance node and connect the footage to it instead. Then press Ctrl-Shift and left-click to preview it. Now, when I adjust the tint, it affects the entire footage. The shadow layer also contains an alpha channel. If we view it, white represents the shadow areas and black is transparent. When we plug this alpha into the factor input of the color balance node, the color adjustment is limited to only the shadow areas. This works because now we're adjusting the color of the actual footage instead of trying to recolor pure black shadow pixels. Now we can actually use this color balance node to replace the alpha over node. At first, the shadows don't line up with the model. That's because the alpha needs to pass through the distortion node first. Once we do that, everything lines up correctly. Now we can control both the color and the intensity of the shadows using a single node. You can also add a color ramp node to tighten the alpha or increase its strength. Next, let me briefly show you some other compositing effects. The glare node lets you add glow effects. I usually set it to fog glow and the quality to high. Then I lower the threshold until it only affects the brightest parts of the image. Be careful not to overdo it, or the image can start to look cheap and washed out. I'll keep the effect very subtle. In the newest versions of Blender, you can find the threshold under highlights. There is also a color field that allows you to change the tint of the glow, which is pretty cool. Then there are a bunch of different settings that you can play around with. Next, there's the lens distortion node. You can use this to add artificial lens distortion on top of any distortion that already exists. Enable fit to scale the image so the black edges aren't visible. You can also use dispersion to add chromatic aberration. This happens when a lens can't focus all colors to the same point, causing color fringing. The jitter control adds noise to the image, which could be used to create film grain. However, there's a better way to do that, which I'll show you in a moment. For realism, it's best to use dispersion sparingly. In older versions, projector forced dispersion to act horizontally instead of radially. With it enabled, distortion had no effect. In Blender 5.0, this behavior is now available as the horizontal type. Radial refers to the barrel or pincushion distortion I showed earlier. In Blender 5.0, chromatic aberration is also available as a separate preset, giving you more control over it. Unlike the lens distortion node, this one mainly affects color channels without mixing them with lens distortion. Offset shifts colors horizontally or vertically. Scale creates radial color separation from the center. Directional blur smears colors in one direction. Lens dispersion simulates realistic rainbow edges near the frame. Lens dispersion is similar to the dispersion in the lens distortion node, but in the chromatic aberration node, it is not tied to lens distortion and mainly drives color separation. Next, let me show you the traditional way to add vignette in Blender. Add a mix color node and set it to multiply. Add an ellipse mask node and connect it to the second input. Adjust the width and the height to control the vignette size. To soften the edges, add a blur node. Enable relative and increase the X and Y values. Instead of darkening the image directly, plug this into the factor input and use it as a mask. This also lets you control the vignette color. Because wide areas apply the effect, add an invert color node before the blur. Using a dark gray instead of a pure black looks more natural. As of Blender 5.0, Vignette is now available as a preset that you can drag and drop into the compositor. It gives you a range of options to adjust the vignette using intuitive controls. You can also use it as a mask for any other effects you might have in mind. Now let me show you how to add film grain. If you zoom in closely, you'll often notice that real footage has a subtle amount of noise. I want to add this noise to the 3D objects as well, so they blend more naturally with the footage. So let's go to the layer where our 3D objects are. The traditional way to add grain in Blender was to add a mix color node and set it to overlay. You would then add a texture node with a noise texture and lower the factor of the mix. However, the result was not very convincing. Because of that, you often had to download film grain textures online. In this example, I'm using a free film grain overlay pack from Gumroad. I extracted the version ending with 002, then added an image node and loaded one of the grain textures. You could add a scale node to match your project resolution and increase the scale to make the noise finer. However, this adds grain as a static image. For animation, the grain needs to move. It turns out the grain we downloaded is actually a movie clip, so you can set the frame range to match the clip and enable cyclic, allowing the grain to loop across the entire animation. The downside of this approach is that overlay also darkens the image, so you then have to rebalance brightness and contrast. Luckily, as of Blender 5.0, there is now a dedicated sensor noise node. The sensor noise node simulates real digital camera sensor noise. It separates luminance noise and chroma noise, and can be animated automatically per frame. Luminance noise affects brightness only and looks like fine grain in light and dark areas. Chroma noise affects color and appears as small colored speckles. You can leave these at their defaults or try adjusting them to make the noise fit the footage better. This makes it faster, cleaner, and more realistic than overlay-based film grain, especially for compositing CG into real footage. Adding a small amount of blur can also help blend 3D objects into the footage. Add a blur node and place it before the film grain. Set it to fast Gaussian and enable relative mode. A very small value is enough. The effect is subtle, but it adds to the realism. In Blender 5.0, it works the same way. The values are just remapped to behave more smoothly. The last thing I want to show you is how to create letterbox borders. Letterbox borders are the black bars at the top and bottom of a widescreen movie. They give the image a more cinematic look by emphasizing a wide, film-style aspect ratio. We can create this using a mask. Go to the end of the node tree, add a mix color node and set it to mix. Set the image color to black, then add a box mask node and connect it to the factor input. At first, the box is in the middle and the footage is outside. We want the opposite result, so add an invert color node. This creates the black borders instead. Now we just need to adjust the width and height. Set the width to 1 so it fills the frame horizontally. Because the footage is 16:9 and the box mask scale is based on the square of the image, the full height is not 1. The correct value is 0.5625, which is the height of a 16:9 image relative to its width. In cinema, letterbox borders usually take up about 1/3 of the screen height, so I multiply this value by 2/3 to keep 2/3 of the image visible. And that's it! We now have letterbox borders with a 1:3 ratio. This step is optional, but it creates a nice cinematic look. And with that, we're finally done compositing. So let's move on to rendering out our final composite as a video. Go to the output properties and make sure the resolution and frame rate are correct. Set an output folder for the animation. Change the file format to FFmpeg video. Under encoding, set the container to QuickTime. This format produces a larger file than MPEG-4, but it retains more data, which gives more flexibility for adjustments later if needed. You can also set the output quality to high quality. Since this is the final render, higher quality helps preserve detail and avoid compression artifacts. In render properties under color management, set view transform to standard. Finally, press Ctrl F12 to render the animation. Now our high-quality video file has finished rendering. Let's bring it back into Blender's video editing workspace. Open a new blend file, switch to the video editing workspace, click Add, then Movie, and select your video file. Similar to the motion tracking workspace, we can also prefetch the footage. In the newest versions of Blender, you have the option to create a new scene or open an existing one. This lets you work on multiple edits at the same time, but I'll just open the existing default scene. Furthermore, the prefetch option can now be found in the end panel of the timeline under Cache. The main thing we'll be doing here is adding some simple sound effects. We'll be using sound effects from Pixabay. You're allowed to download and use these sounds for free, even for commercial projects, as long as you don't resell or distribute them as standalone files. But always double check the license on the site before using assets in your own projects. Click on sound effects. Use the search bar to find a sound. I'll be using two sound effects: a ringing telephone and wind. First, I'll search for old telephone. This old phone sound is exactly what I'm looking for. You can press play to preview it. If you like it, click the download icon and save it to your project folder. Next, I'll look for a wind sound. I want something with a whistling tone that creates an eerie atmosphere. This wind blowing sound effect fits perfectly. Save both sound effects to your project folder. Now we have our sound effects, but I want to make some adjustments to the telephone ringing sound. Since the phone is ringing inside a tunnel, it makes sense to add some reverb and echo. To do this, we'll use a free program called Audacity. You can search for it online and go to the download page. Download the version that matches your operating system. I'm using Windows 64-bit, so that's the version I downloaded. Once the installation is finished, open the software. Drag the sound file from your folder into the editing area. This software is very powerful for a free program, but we only needed to add reverb and echo. Select the sound clip, go to Effect, then Delay and Reverb, and choose Reverb. Open the Presets and Settings panel. In the Factory Presets menu, you'll find many different options. You can select a preset and press Preview to listen to it. To keep things simple, I'll choose the Big Cave preset and click Apply. Now the telephone sounds like it's ringing in a big cave-like environment. To export the audio, go to File, then Export Audio, and choose Export to Computer. Select an output folder and give the file a name, then click Export. If you plan to make more changes later, you can also save the project file. Now go back to Blender and import the sound effects. Click Add, then Sound, and select your sound file. Let's start with the wind sound. In the Strip tab on the right, you can adjust the volume directly. However, I prefer going to Modifiers and adding a sound equalizer. This gives more precise control by adjusting levels in decibels. I'll reduce the volume to about -15 by adjusting the Y values on both sides. This keeps a dramatic feel without being overpowering. In the newest versions of Blender, the Modifiers tab is now found in the outliner. Next, I'll add the telephone ringing sound. Because the clip is very short, the phone only has time to ring twice. However, I want to try to fit 3 rings into the animation. To do that, I'll move the timeline to just before the second ring starts. Then I'll press K to cut the selected audio strip. You can also use the blade tool on the left to cut strips with the mouse. I'll make another cut just before the third ring. After cutting, remember to turn off the blade tool if you're using it. Now I can click and drag the audio strips to fit 3 rings into the timeline. This isn't necessary, but it can help create a more intense feeling. Now I'll gradually increase the volume of the ringing, so it gets louder as we get closer. I'll set the first ring to -16 decibel, the second one to -8 dB, and the third one to -4. This adds a bit more realism to the scene. Finally, we can add some atmospheric music. Filmmusic.io is a great site for royalty-free film music. Go to Music, then Search, then Moods, select Creepy, and click Search. I downloaded this track from the first page. Another free option for music and sound effects is the YouTube audio library. You can use audio from here for your YouTube videos without worrying about copyright issues. I personally also pay a subscription to download music and sound effects from Artlist. Epidemic Sound is another popular paid option for audio. In Blender, I'll hold Shift, select the other audio tracks, and move them up slightly. Then I'll drag the new music track directly into the timeline. I'll choose a segment between 2 peaks in the waveform. I'll set the end frame to where the second peak starts. Then I'll drag the movie clip back a bit to match that end frame. This makes the video slightly shorter, but gives the audio a cleaner start and ending. I'll lower the music volume to -6. It's not perfect, but feel free to fine-tune it further. Now the video editing part is finished. The last thing we can do is give the scene some optional final color adjustment. Go to Render Properties, then Color Management. Here you have several options to adjust the final look of your video. And since this is the final render, now is when you can add view transforms such as AGX or Filmic if you want to. Next, I couldn't end the video without showing you this awesome new feature. As of Blender 5.0, we can now use the compositor to edit footage in the video sequencer. With your footage selected, go to the Strip Modifiers tab and add a compositor modifier. Click New to create a new set of sequencer compositor nodes. Now you can drag to open a new window next to the timeline and set it to the compositor workspace. Then switch from scene to sequencer. Now you can make any final adjustments to your footage using the compositor. This is an excellent time to play around with all the different nodes and effects before we render out the final result. Now let's render out the final video. Just like before, go to the output properties and set the resolution and frame rate. Choose an output folder, set the file format to FFmpeg video. You can choose QuickTime again if you want higher quality, but this time I'll use MPEG 4 since it's more suitable for social media platforms, and we won't make any further adjustments. I'll still set the output quality to high quality. This time the video includes audio, so under audio, choose your preferred audio format. I recommend using AAC or MP3. When everything is set, press Ctrl F12 to render the animation. Now we're finally finished. This is the footage we started with, and after all of our work, here's the final result. We covered much more than what's usually included in a basic motion tracking workflow. Once you get the hang of this, motion tracking and compositing will feel much easier. From there, you can move on to more advanced workflows. For more useful tips on ray visibility and restriction toggles, check out the bonus section on my Create 3D Scenes from 2D Images using FSpy and Blender tutorial. I also have a lot of more tutorials coming up, so if you're interested, don't forget to subscribe. Thanks for watching, and I'll see you next time.